obviously you won't be able to use this table for a test, but now you have something that brings it all together so you can use it to help organize that information for you. So I'm going to get Desmos and talk about Desmos. Okay, so y equals x squared. And let's do y equals, what do you think y equals 3x squared would do to the graph? So let's see what it does.
No, skinnier. Skinnier.
So the red is the 3x squared. So it actually makes it skinnier. Because the reason it does that is it takes the y value and it multiplies it by 3. So it takes that, the x value is the same, and then the y value gets stretched up. So it comes up here. So that's why it's called a vertical stretch. So if I take that vertex, I put my foot down on the vertex, and I take the two sides, I'm vertically stretching it. That's where those words vertically stretch. And if you want to say skinnier, that's okay too. So what if instead of a 3, if I put 1/2 x squared? What do you think is going to happen there? Think about what you think it would do. And it is the red one. The blue is y equals x squared, and it is wider. And it's, what are the other words that I use for that? So vertically compressed. I thank you, those of you that are sitting quietly. So I have my foot on the vertex, and I'm taking the two sides, and I'm vertically compressing the two sides of them. So that's why it's called a vertical compression. Okay, so let's go on to the other side of that page of notes. Okay, so we want to describe the transformation. So we did this before with absolute value. Now we're doing it with a quadratic. So what do you think this 5 in here is going to do to the graph?
Down 5, or not?
It's going to move it to the right or left. Which one? Good. Right. To the right 5. So remember, when it's inside that parentheses there, if we take x minus 5, set it equal to 0, then we get x is equal to 5. So it takes the opposite of whatever that is. So it moves it right 5 units. And then what does the plus 7 on the outside do? That moves it up 7. So whatever that sign is, it's in the y direction, and it moves the graph that up because it's plus. Do you remember that? Does that make sense? Yeah. Okay. So negative x plus 1 quantity squared. What does the plus 1 do? Left 1. Left 1. That's right. So again, on the inside of the parentheses, there it moves it the opposite direction. It's a plus, so it's moving it left. And then the negative on the outside? Yes. You can say reflected, you can say mirrored. You can't say flipped because that's not specific enough. That make sense? Okay, next one. Y equals 2 times x plus 3 quantity squared minus 1.
Is there,
Let
do we have to do the, is there like a specific order?
That's a good question. What do you guys think? There is a specific order. And I'll show you on Desmos why on it. So what do we think on this one would happen first?
left.
Left 3. And so on Desmos, there's x squared.
Wait. Oh. Oh.
So there's the graph on Desmos. So we've got the original graph is the blue, so it moves left 3, and we have this 2 is going to be a compression or stretch?
Stretch.
Vertical stretch. So does it matter if we do the 2 first or do the vertical stretch first or the -1 first?
Yeah. Yes.
It does matter. So what if we did that, we want to do the vertical stretch. So if we say that first, and then we say down 1, this is the graph that we get, this one here. So I'm going to show you the graph that we would get if you did the down 1 first. So the graph is supposed to be the red one. If we moved it down first, if we moved this graph down and then did our vertical stretch, it looks like this, it's like a blue graph there, which is different. We don't want it to be that because the 2 would affect the 1 as well as the 3 there. We want the 2 to be first. We want it to be this order here. Okay, what about number 4?
Let's see.
What do we do first? You want to say right 1. What does the 1/3 do to the graph? Yes, good. Vertically compressed. Makes it wider. And you have to say what it's compressed by. And so it's by 1/3. And then the negative is separate from that vertical compression. Yes, that's a -1/3, but the negative and the 1/3 do two different things. What does the negative do? Reflect it over the x-axis. And what's the last thing that we do? Up. Up 4.
Mhm.
Okay, go ahead and do the U-chart. Any questions on that one? Very common mistake. Students want to say vertically compressed by a factor of 1/3. Negative 1/3 on that one instead of saying those two together.
So, it's a negative and a plus. So yes. Me? Two? Me? No. That's why I won. Stop touching each other. You just. I've already understand.
No, so that's
David? You got David? Or not?
I like Put him in the
What is the Evo? What is hi, what does that mean? Really? What is it's negative. Alright, wait, you gotta read it loud. You can't like you can't pronounce it right. You don't say it loud. No. What does it Say loud. Come on with you know. Yeah, that's what you're asking. No. Why do I get it? So many.
Okay, this should be the answer here. Send them. This should be the answer. Moving on to the next example. Questions on this? Okay. So next example, these ones get a little harder, so you need to pay attention. So we're going the other direction. What's going on?
Boom.
So we've got a function, f of x equals x squared, and we want to write a rule for g. G is going to be our new function, described by the transformation of f. So our new function is going to be g of x.
Wait.
So the f of x is x squared, and it has a vertical stretch by a factor of 2. Where would we put the 2? Yeah, before the x squared. So it's 2, and then I'm going to also do a translation 5 units right. Where would I put the 5 units right? In parentheses. So is it plus 5 or minus 5? Minus 5. Remember, it's opposite. So 2 times x minus 5 squared. Because it says write a rule for g described by the transformation of the graph f. So number 7, a function f of x equals x squared. Let me move this up a little higher. Has a reflection over the x-axis, a vertical compression by a factor of 1/4. Translation 7 units left, followed by translation 3 units up. So what are the vertical compression of 1/4 and the reflection over the x-axis look like? Where do we put that in terms of the x squared?
Equals 1/4.
Positive 1/4 or negative 1/4?
Positive or negative.
Negative because of the reflection. Does that make sense?
Yeah.
Reflection and then a vertical compression.
Yeah. And then x squared.
And we're going to have an x squared, but it also has a translation of 7 units left. Where does that 7 go? Is it plus 7, minus 7?
Plus 7.
Plus 7, because it's opposite.
Yes.
And then 3 units up. Plus 3. That makes sense?
Yes.
Okay. So number 8. This one gets a little trickier. We're starting with the function f of x equals x minus 3 squared. So we want to take a vertical compression by factor of 1/6. What do we do with that 1/6? Where do we put that? Guys? Where do we put the 1/6?
Process.
In the front?
Yes.
So 1/6. And then it was x minus 3 squared, but it is translated 4 units left.
Gotcha.
So when it's 4 units left, does it go plus 4 or minus 4?
Plus.
So if we had a plus 4,
Oh.
that's the hardest part.
Oh yeah.
It makes a plus 1. Does that make sense?
Oh,
Yeah, we did it.
you got it.
And then we want a translation of 3 units up. So where does that 3 units up go?
Plus.
Plus 3. Okay, one last one. What's different on number 9? It's not equal to anything. It's just f of x. This is the first time I've given you one like this. It's just f of x. So we don't have an equation to work with. We just have f of x to work with. So we're going to say g of x, and we're going to take that f of x and do our transformations. So reflection over the x-axis would be where? What does that do? Negative. So we have a negative in the front, and then 4 units right. Minus 4. Where would we put that? Inside the parentheses. So it's f of x minus 4. Does that make sense? And then followed by a translation of 2 units down. Where would the 2 units down go? Outside, so minus 2. Good. You guys did great with that. Okay. On